Welcome to another episode of learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the IIT JAM Mathematics Examination 2024. In this video, we discuss the solution of a problem from the subsection sequences and series from the real analysis. It is a multiple select question for 2 marks and the question number is 32. This question is suitable for all these examinations. In particular, this question is suitable for CSIR, NET and GATE mathematics examination. Right. The given question is, which of the following statements is or true? We are given 4 options. Option A, sigma n is equal to 1 to infinity n times log of in brackets 1 plus 1 by n cube is convergent. Option B, sigma, the series sigma in brackets 1 minus cos of 1 by n bracket close log n is convergent. Option C, the series sigma n is equal to 1 to infinity n square log of 1 plus 1 by n cube is convergent. Option D, the series sigma n is equal to 1 to infinity in brackets 1 minus cos of 1 by root n bracket close multiplied by log n is convergent. Right. Let's now discuss the solution of the problem in detail. We first take the statement that is given in option A, sigma n is equal to 1 to infinity n times log of in brackets 1 plus 1 by n cube is convergent. Right. Now, we have the series, we name it as sigma n is equal to 1 to infinity an, where an is n times log of 1 plus 1 by n cube. Now, note that for each n belongs to n, an is positive. That means the sigma an, the series is a series of positive terms. Now, an is equal to n times log of 1 plus 1 by n cube is equal to n times log of 1 plus 1 by n cube expansion 1 by n cube minus 1 by 2 n cube whole square n to the power of 6 plus 1 by 3 n cube whole cube, that is n power 9. Now we take a 1 by n cube common and there is already n outside the bracket. N into 1 by n cube is 1 by n square, and after taking 1 by n cube common, we are left with 1 by n square multiplied by 1 minus 1 by 2 n cube plus 1 by 3 n to the power of 6 minus so on and so forth. Now, it suggests us to consider the auxiliary series sigma bn as 1 by n square. Consider the series, the auxiliary series sigma n is equal to 1 to infinity bn, where bn is 1 by n square. Note that for each n belongs to n, bn is positive. Right. We now apply the limit comparison test. Limit n tends to infinity of an by bn is limit n tends to infinity of an by bn 1 by n square. 1 by n square, 1 by n square cancels, and limit n tends to infinity of 1 minus 1 by 2n cube plus 1 by 3n to the power of 6 minus so on and so forth. So after taking the limit, you will get 1. 1. So which is finite and non-zero. Non-zero. Therefore, by limit comparison test, the two series sigma an and sigma bn either both converge or both diverge. That means they behave alike. Right. Now, we take sigma bn. Here, sigma bn is sigma 1 by n square is convergent. It is a p series for p is equal to greater than 1. This is a p series test we are applying here, and sigma bn, that is sigma 1 by n square, is convergent. And so, sigma an also convergent. Right, by limit comparison test. Right, the option A is true. We move to the next option in the next slide. Right, option C we have considered. Sigma n is equal to 1 to infinity n square into log of 1 plus 1 by n cube. Similar steps we'll have. We have the series sigma an, where an is n times log of 1 plus 1 by n cube. Note that every term an is positive for every n belongs to a set of natural numbers. Yeah, it's very clear. Now, an is equal to n square into log of 1 plus 1 by n cube. So, n square into the expansion of log of 1 plus 1 by n cube, we have written 1 by n cube minus 1 by 2n to the power of 6 plus 1 by 3n to the power of 9. Now, 1 by n cube is common from the bracket, and when it comes out, it is n square into 1 by n cube will become 1 by n. After taking 1 by n cube common, you will have in brackets 1 minus 1 by 2n cube plus 1 by 3n to the power of 6. Now, it suggests us to consider the auxiliary series sigma bn, where bn is equal to 1 by n. Now, consider the auxiliary series sigma n is equal to 1 to infinity bn, where bn is equal to 1 by n, and each bn is positive for every n belongs to a set of natural numbers. Now, again we apply the limit comparison test. Limit n tends to infinity of an by bn is limit n tends to infinity of an we have written by bn, that's 1 by n. 1 by n cancels. Then we will get limit n tends to infinity of 1 minus 1 by 2n cube plus 1 by 3n to the power of 6 minus so on and so forth. After taking the limit, it will be 1, which is finite and non-zero. By limit comparison test, both the series sigma an and sigma bn, bn either both converge or both diverge. They behave alike as far as convergence and divergence is concerned. Right. We take sigma bn. Let's see what is sigma bn. Sigma 1 by n. It is divergent by p series test for p is equal to 1. So it's a famous divergent harmonic series. Sigma n is equal to 1 to infinity 1 by n is divergent. So in option C, is it convergent? Option C, is it convergent? Is it convergent? No. Therefore, sigma bn is divergent. So, by limit comparison test, sigma an is also divergent. So, in C, it is given this series is convergent. No, it is divergent. It is divergent. So, therefore, option C is not true. So far, option A is true. We move to the next option. Now, we consider option B. Sigma n is equal to 1 to infinity, in brackets, 1 minus cos of 1 by n multiplied by log n is convergent. So far, option A is true. We have the series sigma n is equal to 1 to infinity an, where an is in brackets 1 minus cos of 1 by n bracket close log n. For n not equal to 1, for all natural numbers n not equal to 1, an is positive. Agreed? Agreed. So is the series of positive terms. So we take an log n into 1 minus cos of 1 by n. So it's equal to log n into 1 minus cos 1 by n expansion we have written. That is 1 minus 1 by 2 factorial into n square plus 1 by 4 factorial into n power 4 in the denominator itself minus so on and so forth. And expand now minus of this bracket 1 minus 1 will cancel and you are left with log n multiplied by 1 by 2 factorial into n square minus 1 by 4 factorial into n to the power of 4 plus so on and so forth. Take 1 by n square common from the bracket. So you will get a log n by n square is equal to 1 by 2 factorial minus 1 by 4 factorial into n square plus so on and so forth. Right. Now this suggests us to consider the auxiliary series sigma bn where bn is equal to log n by n square. So consider the auxiliary series sigma n is equal to 2 to infinity bn where bn is log n by n square. Very clear, for n greater than 1 bn is positive, right? Good. Now limit n tends to infinity of an by bn, we are applying limit comparison test. Limit n tends to infinity of the numerator an by the denominator bn is log n by n square. And log n by n square cancels and we are left with the limit n tends to infinity of 1 by 2 factorial minus 1 by 4 factorial into n square plus so on and so forth. After taking the limit, it is 1 by 2 factorial which is finite and non-zero. So by limit comparison test, the two series sigma an and sigma bn behave alike. That means either both converge or both diverge. Now we see bn, sigma bn. Here sigma n is equal to 2 to infinity bn is sigma n is equal to 2 to infinity of log n by n square is convergent. How? We will show you in this snippet. Right. It is known log n means natural logarithm ln n grows much slower than any positive power of n. It grows very slow. So log n is less than root of n for sufficiently large values of n because it grows much slower than any positive power of n. The positive power is 1 by 2 we have taken, and for sufficiently large values of n, log n is less than root n. Therefore log n by n square is less than root n by n square. There is a print mistake here, not n square. Root n by n square, that is 1 by n to the power of 3 by 2. Right. So by direct comparison test, log n by n square is compared with 1 by n to the power of 3 by 2. And sigma, by direct comparison test, sigma bn, that is sigma log n by n square is convergent because the series sigma 1 by n to the power of 3 by 2 is convergent by p series test for p is equal to 3 by 2 greater than 1. So thus sigma bn is sigma log n by n square is convergent. Right. Therefore by comparison test sigma an is also convergent. That means option B is true. Option B is true. So far option A and option B are true. We are left with one more option. Let's get into that. Lastly, option D. Sigma n is equal to 1 to infinity in brackets 1 minus cos of 1 by root n log n is convergent. So far we have seen options A and B are true. We have the series sigma an where an is 1 minus in brackets 1 minus cos of 1 by root n bracket close multiplied by log n. For n not equal to 1, n belongs to a set of natural numbers. Each term an is positive. This is a series of positive terms. Right. We take an Now we write the expansion for cos of 1 by n. Log n multiplied by 1 minus cos 1 by n expansion. 1 by n expansion. 1 minus 1 by 2 factorial into n plus 1 by 4 factorial into n square minus so on and so forth. Log n is the natural logarithm ln n. Right. Expand now. Take out this minus sign, minus 1 plus 1 cancels, and you are left with log n into 1 by 2 factorial into n minus 1 by 4 factorial into n square. Here is a mistake. Here is a mistake. An is in brackets 1 minus cos of 1 by root n. Root n into log n. So here there should be a root n. So when you expand, this is the expansion for 1 by cos of 1 by root n. Not cos of 1 by n, I am sorry. Cos of 1 by root n. That is 1 minus 1 by 2 factorial into root n whole square, that is n, plus 1 by 4 factorial into root n whole to the power of 4, that is n square. So 1 and minus 1 cancels, and you are left with log n into in brackets 1 by 2 factorial into n minus 1 by 4 factorial into n square plus so on and so forth. From the bracket, we can take 1 by n common. That will log n by n is into 1 by 2 factorial minus 1 by 4 factorial into n plus so on and so forth. Right. Now it suggests us to consider the auxiliary series sigma Bn, where Bn is log n by n. Consider the series sigma Bn, n is equal to infinity, where Bn is log n by n. Where here Bn is positive, each Bn is positive for all n greater than 1, right? Right. We apply limit comparison test. Limit n tends to infinity of an by bn is limit n tends to infinity of an by bn log n by n. Log n by n cancels, and you are left with limit n tends to infinity of 1 by 2 factorial minus 1 by 4 factorial into n plus so on and so forth. Take the limit n tends to infinity. It will be 1 by root 2, which is finite and non-zero. Therefore, by limit comparison test, the two series sigma an and sigma bn behave alike as far as the convergence and divergence is concerned. That means to say these two series are either both converge or both diverge. Now here sigma n is equal to infinity bn is sigma n is equal to infinity log n by n is divergent. How? We will see here. Now note that log n is we have said natural logarithm ln of n greater than 1 for all n greater than or equal to 3. Therefore, log n by n is greater than 1 by n for all n greater than or equal to 3. By direct comparison test, sigma bn, that is sigma log n by n, is divergent because sigma 1 by n is divergent by p series test for p is equal to 1. Thus, sigma bn is divergent. That's what we have written. Therefore, by limit comparison test, sigma an also divergent. That is, sigma n is equal to 1 to infinity, 1 minus cos of 1 by root n multiplied by log n is divergent. Yes, we have written correctly 1 by root n. Here itself 1 by root n should be there, but we have written 1 by n is a typographical error, but the expansion is for the cos of 1 by root n only is written. No problems. So it is divergent. But in option D, it is given to be convergent. Therefore, option D is not true. So far, options A and option B are true. The answer to this question is options A and options B. They are true. That is the detailed discussion of the solution of the given problem. For a BSc student, it will be a time-taking problem. But however, it's not a difficult problem. But this question is suitable for mostly the CSIR NET and GATE mathematics examination. Even TG set exam also this question can be asked. Right. I am sure that you have understood the solution of this problem. I thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Yes, definitely. I will meet all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.